hold on. Can you pause this?
Remember, fractional exponents are what? Oh,
Ow! Oh, Misty! I hit the funny bone of my kneecap.
and it wasn't funny.
Burning.
I put a sunshine in parentheses so you would remember. Fractional exponents are nothing more than radicals. Keep that in mind. So if I said x to the 1/2, you would know that that's the same thing as
Square root x.
woo, we were going to get it out eventually, right? All right, or if I said something like, all right, so this is the same thing as what? Sunshine it.
Of a plus 2.
All right, yes, the denominator is the root. The denominator is always the root. Right, Jonathan? Say right, that's right. Say right. That's right. Okay. Right. The denominator is the...
It's a number. It goes.
The denominator is the...
You divide by. The bottom number. The root.
The root.
The root.
Thank you, whoever helped him out over here. Okay. All right. Now, also, before I show you the equations, tell me this. If I had x squared equals 25 and you were solving that for x, okay, but tell me what you're doing. What operation cancels it out? A square root, right? Now, why is it a... Why does this cancel out, though?
Because the square root of the square cancels out.
Okay, do this for me. Sunshine the square root of x squared. And tell me what happens. Sunshine this.
Can we not make this one Let's stop it now because I don't like this whole
Which means what, Jonathan? What? What does that mean? 2 over 2 is what?
1. So it's just x. Do you see? Do you see why this cancels then? Opposite operations cancel each other out, right? So let's talk about some opposite operations so you'll see where this is coming from. Plus, addition and subtraction. These are opposite operations. They cancel each other out, yes? Multiplication, what's the opposite? Division. Now, square root. What's the opposite operation? The square. In other words, what cancels it out? Right? The square root and the 2. What if I said cube root? What's cube? Opposite operations, right? Are y'all following me? At the end of the day, if I had x to the, let's say I had x to the 1/2, okay? And I raise it to the second, what do you do when you raise a power to a power? You multiply. What happens if I multiply reciprocals? They cancel out. It becomes 1, right? So this just becomes x. So any exponent I have to get rid of it, well, because you have 1/2 times 2 over 1 is 2 over 2. Top times top, bottom times bottom. And 2 over 2 is... With me? Okay. All right. So I want you to okay. Does everybody understand that much? Okay. Let's solve what? Oh dear. I'm on calculuses.
The 30.
can't? I'm wondering if I can cut it. All right. Okay, so we talked about the opposite operations. We talked about changing the roots into radicals. So now let's talk about how we're going to get these alone and we're going to solve them. If I have something like, and this, I'm going to say this is, I'm going to talk about two scenarios. Scenario number one radical. If you just have one radical in your equation, something like the square root of x plus 5 is 12. I've got to solve it for x, but we have done something very similar to this. We're going to crank it up, but I want to start with music. Yeah. We're going to isolate the radical, and then we're going to get rid of the radical. Okay. Then you wouldn't have to do all that, but we're talking about the variable being in the one radical. So square root of x equals, I subtract the 5, I get 7. Square both sides because the squared is the opposite operation here, right? Right? Right, okay. So x is 49. Now, as we solve these, I'm not going to make you do this, but I need you to know what this means because this will come up on like your SATs and stuff, and I need to at least mention it so you know. Yeah. Yes. Yes. Sometimes, tell me how when you solve an equation you check your work. What do? You plug it back in, right? You plug it back in, do it in reverse, check it, make sure. Well, sometimes when you plug it back in, it won't work, okay? This time it works, but sometimes you will have done every single thing right and followed all the right steps and get the right answer, but when you plug it in, it doesn't work. That's what we call an extraneous solution. Come on. The reason is because square roots have a positive and a negative root. So sometimes when you solve them, one of it doesn't work. Right. Right. It could make a positive. Right. Right. So extraneous solutions happen when you plug back in and it doesn't work. Now, I'm not going to make you do that because it's twice the work. You solve it and you plug all your answers in and you figure out which one works and which one doesn't. It's a lot of work. But I do want you to know what it means so that if that comes up for you at some point in the future, you will know exactly what it is they're talking about. So it's not a true solution even though it works whenever you solve it. All right, let's keep going. Let's do another one. No. It just means sometimes you'll get two answers whenever you solve, and you'll go, oh, wait, that's an extraneous solution. It doesn't work. We won't be doing it. I'll just have you find all of these. Let's do another example. Edwards. Yeah. And then we're going to crank it up just a bit. Okay. All right, don't blurt this one out. Try it on your own and see what happens. Mark, say go. As you begin this one, remind me, I think I forgot to remind you, what does the word isolate mean? By itself. By itself, completely by itself. I get rid of a negative. You could add the root. Are you saying add it instead of subtracting the other? All right, a couple of you are doing a couple different things, and nobody's wrong that I've seen so far. You can subtract the 3 from both sides. That works, and you get negative 4th root of m equals negative 3. And then divide by negative 1 because I want the radical completely isolated. And I get the 4th root of m equals 3. Now, the other way to get to this point and one step less, which is what Aubrey was talking about, is you could just add the 4th root of m to both sides now so that you end up with 3 equals the 4th root of m. It doesn't matter which side of the, either way you get the same thing. Way faster, a little less work, yes. Yeah, and got a positive. The only problem with that is because if it was a number in front instead of just a negative, you would have to raise that number to the 4th power also. There isn't. Right? Yeah. Correct. All right, so look. I'm going to get rid of this radical. How do I get rid of a 4th root? You put it, yes, you can. You put it to the 4th power. If I do it to one side, I have to also do it to the other side. So I am going to cancel them out, and I get m equals AT1.
Yesterday, Tom.
All right. Eliminate it, right, by squaring. But if you square that side, is that y squared minus 121? Say it again, Riley Grace. You cannot distribute an exponent when you are adding or subtracting inside the parentheses. You have to FOIL it.
Wait, so that's when.
That kills the puppies. Puppies.
No!
The puppies. Just do it for the puppies, Sawyer.
They're gonna kill Matthew's new dog.
They're eating the dogs. They're eating the cats. Okay. 51 equals 5y, or 51 minus 5y equals. I was going to say, nobody even laughed, and I thought it was pretty funny.
I wouldn't laugh. I don't
But they, you know, they play. Have you not seen that anymore?
The dog breeding the cat.
Eat the dogs, eat the cats. You've not seen that anymore, than do. That's a 121. That's 121.
So how do you get that? Wait, what? Oh, to get the.
I'm moving all these over. I'm going to do minus 51 plus 5y minus 51. What's 20, negative 22 and 5?